I'm wondering if I can't teach over this. You know what? For the sake of science, let's smooth jazz this shindig. So, what we're going to be talking about in today's class is, well, we already talked about dynamic stresses. What we're going to be talking about now is welds, okay? Last week we talked about bolts. Bolts, valuable, useful. Lots of things that you have to consider when designing for bolts, but usually bolts themselves are pretty straightforward. This week, we're talking about welds. Okay? Now, what is a weld? Well, a weld is when you friggin' melt metal to join two pieces of metal together. Okay? Alright, it is possible. There are some kinds of welds. Yeah, unfortunately, Walker, yes, it is a huge distraction for me. Yeah. But we'll see. We'll see if my ADHD can handle this. So far, so good. I already wrote words on the board. So I'm already in a good place, right? The need to air guitar is increasing though. Sometimes when you weld, you're actually melting a piece of the metal to join to the other piece of metal. Sometimes what you do is you use an external filament. Both of those are pretty standard. There are different types of filaments that are used to melt it. So basically the process of welding is you'll have two components. You'll bring in a filament and you'll bring in something hot, which I'm just going to represent this as a spike. You touch the filament to the hot piece and you try to melt it down here. It's soldering, just with stronger metals that where they don't care as much about the electrical conductivity. Okay, that's really just soldering. That's basically it. There are different types of welding. You got MIG, TIG, just different ways of creating that heat. Different tools used to create the heat. So there's a lot of different types of welds that can be created. Now, do be aware that unlike some of you in this class, I've never welded before. And some of you are much, much, much better, and you probably already understand welding. But my purpose in talking about this class is the academic side of it, which is how to understand designing for welds. Okay? If you are trying to create a weld, you're trying to create a 0 degree of freedom joint. The purpose of having a 0 degree of freedom joint is to affix two components to each other, okay? You may have maybe a plate and you're trying to mount a bracket, just slap it onto that plate and you'll weld all the way around the outsides of it, okay? Different applications of how you're welding, what kind of forces are going to be carried through that weld, that does determine the kinds of welds that are needed. And here's where, I know for a lot of components, I continue to just say, go refer to your book. But seriously, go refer to your book. The book does an excellent job of discussing different types of stresses, different ways that stresses are carried through welds, different types of welds, etc. In chapter 9, that's the chapter on welds, it even gives all of your welding symbols. So you've got bead welds, fillet welds, plugs, square, V, bevel, all these different types of welds and how to really calculate them. So just here's some symbols on how you would show the weld. So again, it's just a really good resource. I'm sure you could Google all this. You can Google everything. But I like this book because it takes all of this information and puts it in a very concise fashion. It's up to date, it follows standards, and that is appropriate. Now, the way that a weld works is, let's say we have two surfaces like here, and we're building just a fillet weld inside of here. Okay, it could be a spot weld. In a spot weld, you will do a fillet weld like so here. If this is your joint, you're connecting a piece that looks like this with a piece that looks like this, and you're doing a fillet weld here. A spot weld means it only goes every once in a while. It's not a continuous bead. Spot welds are used when you need components that are affixed together, but it's not going to carry a ton of force. Spot welds are a lot faster, substantially lighter than doing a full weld. So they're very common in industry. Spot welds are everywhere. Yep. Dang it, Walker, you saw the future. I do not know if I can handle smooth jazz. I need to figure out a way to make it so that smooth jazz shows up on a live stream and not me, so I can't hear it. I'll figure out a way. There's got to be a way. So when you have these spot welds, again, all of the force that's being carried, this is, any forces that are transmitted this direction, are only being carried through a small area. You don't have force that's being transmitted down here at the bottom. This is not your location, your force transfer. It is through your spot welds. So the important thing when designing welds is that you have to design them such that they can handle the appropriate forces. Okay? Now, what happens is, as you push on here, this generally creates a resistance to that force that is then transferred into a shear force down here. That's just the way that it is. Similarly, you pull up on this, it creates a shear force here that is transferred to a normal force down here. Shear to normal, normal to shear, that's pretty average. There are different ways of calculating all of those. The book gives 10 million different formulas based on the type of loading, torsion, bending, all of that. At the end of the day, though, what matters a lot to the engineer comes down to this table. This is table 9.6. And what this says is, it says, here's the allowable force for your various sizes of fillet welds. So you have a 1-inch leg on your fillet weld, you have 1/16 inch leg on your fillet weld. It's going to be able to handle, for the 70 strength level of weld metal, it's going to be able to handle 930 pounds. Okay, so awesome. Per inch. So you have a full inch of 1/16 weld. It's going to be able to handle 930 pounds. Okay. And you can use that chart to really figure out, okay, how much force am I going to be transmitting? How much load do I need to have? And that's it. That is figuring out force loading. Now, as a machine designer, which I just realized Yeah, I've been doing some digging work this weekend, and my nails are still really muddy. And I just showed that to the camera. I bathe, I swear. Just have very dirty hands. Wow. Yeah, I cannot do this with jazz. I'm gonna see how this lecture turns out, but everyone of you knows I have dog-like tendencies where I can't focus on things. Like lights, shiny objects, sounds, everything distracts me. This is definitely one of those things. Okay. So determining the forces that it can handle, that's great. Now, as the designer, what you need to recognize is that there is some fatigue involved too. That is for a static force that is applied. In order to take that and do your fatigue, you have to then go and you have to modify all of this, okay? Understanding fatigue, oftentimes it's just a value that you multiply it by. Like you take your force and you multiply it by your fatigue force, which may be something like 1.5, and you say, okay, then I need to be able to take a weld that can handle a force, and the maximum force that I'm looking for is 1.5 times the actual force that's being applied to it, because I'm taking into account fatigue. That does depend on your different types of weld materials, but I do believe that is discussed in the textbook. It's a lot simpler to design for weld fatigue than I guess it should be. Yeah. Well, anyways, so that's it. When it comes to welds, you really just have to figure out how much force is being transferred through this joint, figure out an acceptable material that you're going to be using, and then figure out how wide and deep those welds need to be in order to transfer that force. That's it. You did a lot with force transmission in calculating the power that goes through your mechanism. You do a lot with force transmission again to figure out how much force is being transmitted through the welds. And that's the gist of welds. It's very straightforward. Right. Tyler hating. It's jazz day. You can't shut off the jazz. Sick. Okay. That's it for this week. I forgot to give you a reading assignment last week, which is awesome. Which means I will be giving you a reading assignment for next week. I am going to post a quiz today, due this Friday. So be watching for that. You do have an assignment this week. That is a quiz. That quiz will be over bolts. Because you did your reading assignment, you watched the lectures, etc. We will have a quiz next week on welds, and a quiz next week that also, no, we're going to have 2 quizzes next week. Both of them are going to be a cumulative review of the entire class. And then basically I'm just taking one quiz and splitting it in half so that it has twice the weight. That's it. But I'm giving you 2 different quizzes so that I can just keep to that 10-point quiz value. So you'll have a reading assignment due next week, 2 quizzes due next week, 1 quiz due this week, and you got a paper due in 2 weeks. So you've got a lot to keep you busy. We will not be having class this week. I have some things I have to take care of for a live stream. But we will have class next week, and then we're done with the semester. So I will see you next week. Enjoy learning I need a better catchphrase.